So estimate the model, create estimate equation. This one, so just usual. So y space c space x1 space x2 to get the estimate. Okay. So you have the estimate beta 0 hat, beta 1 hat, beta 2 hat. So you have standard error of estimator. T is statistic, but remember it's a value lah. But I mentioned before, the one that given in the combinator output always for the case of null hypothesis equal to 0. But in our case now, in our this question, it asks us to perform the test that the null hypothesis beta 1 equal to 7.5, alternative not equal to 0.5. So you cannot use this one. You cannot use this one, you have to calculate your own T statistic. And you cannot use PV, this one PV as well. So you have to, you can use the estimated value of coefficient. Standard error you can use, but you cannot use this one because this one is calculated by simply taking ratio between this divided by this. But for this test, for this hypothesis testing, you have to minus the hypothesis value. Estimated value 2.7.4 something minus hypothesis value divided by SE. Okay. So you need to calculate your own. So the one given in the obvious output only doesn't matter like if you use Excel. Okay, it's always for the case of the hypothesis value equal to 0 against alternative not equal to 0. So if you calculate, so you get 0.01366 compared to the critical value from T table. So let's say it's 5% level because two tail tests you need to divide by 2. So I hope those who still do not understand, so please make sure you know. So this one, let's say normally you perform the test at 5% significant level. If 5% significant level, so you have two tail tests equal not equal to tail test. Remember, one tail test is for the case of your alternative greater or less. Greater or less, alternative greater one tail test the right side of the distribution. If less, the left side. So that determines whether positive or negative, greater or less, it determines which side your rejection region. Yeah. So this one two tail test. So this one is less than critical value from table, so you do not reject. So you conclude that we can say that it is safe for us to make conclusion that beta 1. We can agree that beta 1 equal to 7.5. Okay. So we based on the results suggest that it is safe. It is quite safe for us to say the true value of beta 1 equal to 7.5. The estimate 7.4. This estimate from a sample. You understand? Difference between actual true value of parameter, we just like x bar and mu, mean for population and the average for sample. This is as our estimate. 7.4 our estimate. But we want to use the estimate to help us to say whether we are confident that the true value is equal to whether it is safe for us to say that the true value parameter is equal to this. Okay, so we perform hypothesis testing. So that is the use of hypothesis testing to help us to decide whether it is safe for us to reject or not reject, to reject or not reject, you have to decide. So in this case, it is safe for us because we do not reject analysis, so it is safe to, we can agree that the true parameter value is equal to 7.5. Yeah. That's the first approach. Second approach is the walk test. You have to estimate full model and mixed model. So I'm not going to show how to estimate because I already explained before. But this one, I just show you how to get that result in EViews using easy way. Because I mentioned before for the midterm test, no need to use the difficult way. You just use the easy way. Okay. So for example, in this case, you can just need to estimate the full model, and then we perform the walk test using the what we call the walk test. Okay, instead of not need for the midterm test, not need to estimate full model. If the model not need to calculate manually this one. So this one this one I leave it to you to do the manual way at home. So meaning that manual way you have to estimate full model, and then what happens if you now have this issue? What happens to the model? Then beta 1 equal to 7.5. So what happens? So you can break this to the right, to the left. So it becomes a new independent variable, and then you regress again this one. So you get SSE for the full model, put the model, receive the model, and then you calculate and you compare this value to the value from F table. Okay. So if you use EViews, you have this one. So you want to test that beta 1 equal to 7.5. Okay. So again, for the midterm test, if I ask this kind of question, just use the easy way. Okay. The easy way, you just estimate each model, and you go to view, go to coefficient diagnostic, select walk test coefficient restriction. Okay. Walk test coefficient restriction, and then you specify the coefficient that you want to test. So coefficient number 2 because beta 1 beta 1 coefficient number 2 based on the order that it appears here. How it appears here. Okay, the order for beta 1, our estimate is number 2 like S1, coefficient for S1, beta 1. So beta 1 coefficient number 2 here. Because the coefficient number 1 for set C, coefficient number 1. Okay, so coefficient number 2 equal 7.5. So we should get the same test statistic. Whether T statistic for the first approach, you have the walk test 0.0, and P value the same. So P value greater than 0.05, so we do not reject analysis. Say we conclude that we are able to agree that the true value of parameter that represent the effects of x1 on y is equal to 7.5. One C perform the hypothesis. Beta 1 equal to 15, beta 2. So meaning that again, let's say someone says that I believe that the effects of x2 on y is equal to 15 times of the effects of x1 on y. So meaning that it suggests that beta 1 equal to 15 times. Sorry, meaning that the effects of x1 is equal to 15 times of x2. So meaning that beta 1 equal to 15 times beta 2. So the same model, just estimate the same model, then you go to view, coefficient diagnostic, walk test, coefficient number 2. equal 15. So equal 15 times of coefficient number 3. So this one is single restriction. Okay. So you get f statistic 0.0004, and then this one p value greater than 0.05. This one also the same lah, do not reject. So again, we can agree that at 5% significant level, we can agree that the true value of beta 1 is equal to 15 times of the true value of beta 2. So this one also I leave it to you to do the manual way. Manual way, you need to estimate the full model and then the restricted model. So what happened for the true model? If the none of this is true, then it becomes like this one. And then you have to regard this with this to get SSE for the restricted model, and then compare the values to eventually from F table. Question number so question number 2, this is more than 1 2 restriction, so this is a multiple restriction. So given the data here, number 2. So given this data and then this model, so perform the test that coefficient number beta 4 equal to 0 and beta 3 equal to beta 5. Okay, so although this test is not just the test that we frequently do, but it's possible now. So there is possible there is a situation, it's possible that this situation requires us to do this kind of test. Okay, although it's not normally we perform the other tests like the significant test equal to 0 or not, and then the joint testing for all the significant of all what we call the skill parameters. So this one, estimate in order. This one close first. So question number 2. So just estimate in order. Quick estimate equation. So you have y space c space x1, x2, x4, x5. Okay, so to perform the test, Then beta 1 equals 0 and beta 3 equals beta 5. So you go to view again, coefficient diagnostic, walk test, decision. So again, so you have to identify which coefficient. So coefficient with beta 4 coefficient number 5. Okay. Coefficient number 5 equal to 0 and then comma second addition. Beta 3 equal to beta 5, so coefficient number 4. Coefficient number 6. So again, this one I leave it to you to do at home, the manual way. So estimate the full model, but again for the test I will not ask you to do the manual way. So you can just use the easy way like this. But it's good for you to know. The manual will help you to understand. So not only produce the result and interpret, you have to understand as well. It's good that you understand how it is what we call it, it is produced and so on. The formula, the test statistics, how it is calculated. Okay. So you get 0.0225, and the good things about computer output or this output that it provides p-value as well, so that you can easily make conclusion based on p-value. So this one also the same, because p-value is greater than 0.05, do not reject, and then conclude that it is safe for us to make conclusion or to support or to create value hypothesis. That suggests that the true value of beta 4 equal to 0 and beta 3 equal to beta 5. Question number 2C, given, so this one the overall significant test, test the overall significant. So based on F test, the F test you can get from here. So this is the F statistic and p-value. Okay, the F. So you can get from here the F statistic and p-value, so you can easily make conclusion based on p-value. So of course, you can test means that we perform the test, the joint possessing for all slope parameters, beta 1, beta 2, beta 3, beta 4, beta 5, all equal to 0, alternative at least one not equal to 0. So for the overall significant test, you can just use the statistic here as a p-value. So p-value smaller than 0.05, so we reject. But here, if let's say you don't have this value, let's say for final exam, for example, you are given question, but you don't have this one. You don't have this, but you only have the R square. You can use this one. You can use this alternative way to do the calculation, because using the given formula is one. Because if all coefficient equal 0, then your restricted model, you only have intercept. If the null is true, if the null is true that all coefficient equal to 0, then you only have this one. You only have intercept, the 0, because this one 0, 0, 0, 0, 0. So you don't have this. You don't have this anymore. You only have intercept. Okay. So if any model, a model only consists of intercept, then the R square equal to 0. Okay. So if you regress, if you, for example, estimate y against c only without x, and then your R square just 0. Because why? Remember, because you don't have any x to explain. Remember, R square means what? R square means what? R square means that the portion of variation in the dependent variable that can be explained by your x. You don't have x to explain y, then 0. You cannot explain. Okay, so just 0. If you don't have x, you only have intercept, then your R square equal to 0. So you can use this. Let's say you don't have, you are given information, this one, but you don't have, you only have R square, but you don't have the F statistic and the p value. So you still can perform the test, because you know that if all coefficient equals if all slope coefficient equal to 0, and then your R square, if the R square must be 0. The R square for the different model, so you can calculate the one. You can calculate using R square, and then you get compare this to the predicted value. Okay, that's one question number 3. So that session 3 we have to discuss next week. We discuss last question. So this is the job test, another example. So we have unemployment rate as well as job question, what would be, and then perform stability test in order to identify if the parameter still stable or not for the two different periods, before and after 19 before 1962 and the period after that. Okay. So question number 3, use file. So you need to estimate model. So create estimate equation. So your dependent variable is UN, and then your independent variable is V. So here we want to test whether both intercept and slope parameters for V remain the same for the two different periods, or no longer the same, stable or not, stable or not. Meaning that if not stable, then we cannot use the pool data, and we have to split data, or meaning that maybe we should use the research data only to estimate, because the results shows that the relationship between UN and V no longer the same for the entire period from the beginning of the year and the end, and until the end of the year. So your estimate is one, and then to perform the stability test, you go to view. So again, so I mentioned before, so just ignore the estimate model is not, the estimate is not that reliable because it has the problems of autocorrelation. But for now, we ignore the problem, we assume it is okay, we satisfy all assumptions. So we go to view, stability diagnostic, the Chow Breakpoint test. So remember this one, you have to put the points or the times, the first one in the second subsample. So let's say now it's speed data 2. The first data until 1961, and the second one is starting from 1962 onwards. So this one you have to put 1962. Okay, so you get your after statistics like p value. So 88.95, p value 0, you reject. So reject means that we know that there is any other parameter that's not stable, whether intercept or slope parameter, whether beta 0 or beta 1, but we don't know which one. Okay, so we reject, meaning that parameter not stable, not the same for two different periods. So we have, we should not estimate model based on the results. Suggest that we should not estimate model using entire data set. So we have to, for example, just use the recent one. Okay, in order to get more stable estimate. So for this one, please try to do the main way at home. So meaning that you estimate the funds per model, and then you estimate by changing the range, sample range for the first subsample and the second subsample, and then you get the SSE, and then you can calculate using this formula. Okay, and then compare to the critical value from that table to make conclusion. So this one SSER for the full model original using all data, and then you split data into two subvariant, and then the first sample, second sample. Calculate that here, same, and you compare with the critical value from that table. Because the F is greater than critical value, so reject. So we do not know. So later on, when after we discuss dynamic variable, then I will explain to you how to use dynamic variable in order to identify which parameter is not stable, whether it's a set or a slope. That one. For this test, we do not know. We can only conclude at least one parameter not stable. Intercept or slope, either one or both not stable, not the same before and after. We do not know which one. But later on, after we discuss the dynamic variable, then we have alternative way that we can use to identify which one is not stable. Okay. Alright, so I think that's all for today.